Good afternoon, everyone. My name is Romain, and the title of the speech today is I'll never be late to school again. So, it's 9 a.m. in the morning, you wake up, you live in Waikiki, you could kill someone with your breath, you smell like horse sweat, your hair is pretty much like this, but most of all, you have class at 9:30 a.m. In this situation, whatever choice you make, you're done. Because it's either you take the minimum of time to prepare, just the minimum, and then you get half hour late, or you just go to class as soon as you wake up, you get to class, and then you wish you never did because you're horrific. So these are situations that happen much more often than what we think. At least for me, for our dear friend Laure. Laure, actually it's Laure, sorry. Because we're from a polychronic time culture. It happens much more often than what we think. But I don't know what you guys think in this situation, but something that always came up to my mind, one thought that always came up, is if only I had teleportation. Insane. But not that much. What if I tell you that nowadays, researchers actually succeeded in teleporting something? This is what I'm going to talk about today. So we'll first look at what is teleportation, where does it come from, then before getting to the real subject, which is quantum teleportation, then we'll talk about why it is problematic to talk about human teleportation, and we'll finally end by why we should not give up on the idea of human teleportation. So, what is teleportation? Well, it's a term that was coined in 1931 by a science fiction author writer, which was called Charles Howard Fort. Something like that? Yeah. Charles Howard Fort. In his third book that was called Law. So the etymology of the word teleportation comes from the Greek word telos, which means distance, and the Latin word partare, which means to carry. And according to IBM, the first definition of teleportation at this time was the feat of making an object or a person disintegrate in one place while a perfect replica appears somewhere else. So if you listen to this definition of teleportation, then just forget about it. It doesn't exist. Simply because it doesn't follow one basic rule of physics, which is nothing is created, nothing is lost, but everything is transformed. And according to this fact, for many, many years, researchers actually laughed about the idea of teleportation because it was just not possible. Although, a small group of 6 researchers, actually one of IBM, this is why they had the definition of teleportation, made more deep the research about teleportation and came out in 1993 with a proof that the principle of teleportation was possible. And this is when we get to a new term of teleportation, which is quantum teleportation. What is quantum teleportation? It's simply the teleportation that follows the basic rules of physics that I just enunciated before. So according to Nicolas Gézin, a doctor in physics at the University of Genova in Switzerland, how does it work? Basically, you have one object in point A, okay? When you want to, during the process of teleportation, this one doesn't disappear. It's formed, like it's still here, you still have the materials, but you don't have the form of the banana anymore. Although, at the same time before, at the point B where you want to make your teleportation, you already have the materials, but not the form, which is this, and after that, ta-da, you get a banana. Right? So how is that even possible? How can we make one banana curve from here to have the exact same replica on a point B without traveling in the middle, like physically traveling? Well, it is thanks to a very basic, actually it's not basic, it's kind of crazy, of the physics principle called entanglement. So, in order to explain you and try to make it clear, I'm going to use an example that was a success actually the first time in the University of Tokyo in 1997, which is the first real achievement in teleportation. So basically, what is entanglement? At this time, they took two particles of light, also called photons, two, for example, blue particles of light. They make it connect together, really interact together. Because of this, both of them create a hole, like one hole, and they create links together. Though they are still two particles. So once, if they are entangled, once you take them apart, even though they can be like one from one side of the Earth and one from the other side of the Earth, they are still connected together. And if one reacts, the other one reacts too. So for example, I have on point A a blue photon. We make it react with a yellow photon. Both of them react together, you get a green photon. At the exact same time, instantly, on the other side of Earth, the other photon gets green as well. So I know that it's crazy, it's kind of magic, and actually researchers don't have explanation for that. They don't really have explanation for that. It's just, this is one thing, it works like that, it's principle of entanglement, and you don't question it. Although, once this first success occurred, the questions like, can we teleport humans came up, of course. Although this particular teleportation with just photons permit only like teleportation of one atom by one atom. But humans, which means us, we are made of millions, thousands of millions of atoms. Which means that to teleport the whole human body, it takes about 15,000 million years, which is about 3 times the age of the galaxy. So of course, it wasn't possible. And some people actually gave up on the idea of teleporting humans. But they shouldn't. They gave up on this idea, but they still see like a great future about quantum teleportation in terms of communication, because it's instant communication, it's 100% sure, because you don't have wire or whatever, it's perfect. Although recently, very recently, Eugen Polzik and his colleagues at the Niels Bohr Institute in Copenhagen, together with the researchers at the Institute of Photonic Science in Barcelona and the University of Nottingham, have succeeded recently in teleporting a macroscopic quantum spin state of chiasms. So how did they do it? They actually found a new way of entanglement. Not only two photons together, but two gases together, which means that they could now teleport like millions of atoms at the exact same time. And that gives hope, maybe later, maybe not like during our lifetime, that maybe later we'll be able to teleport humans. So today we've talked about teleportation. I defined it, what it was, where it comes from science fiction. We've talked about what was quantum teleportation, which means like basically a version that was possible with the actual law of physics. And we've talked about the problematic of human teleportation and why we shouldn't give up on this idea. So now, dear classmates, cross fingers, maybe some days we'll be able to sleep 30 minutes more and still be on time class. Thank you for your time.